In this video, we are going to talk about VLANs. VLANs, what are they? What do they do? How do they work? Well, a VLAN stands for a virtual local area network, and it's a logical way to segment a switch into multiple broadcast domains. Once you create a VLAN, you place a port into a VLAN. So let us go ahead and dive right into some of the explanations as to how this works and taking a switch and putting in the different VLANs and building out how we're going to go forward here. So in our topology that we have for our layer 2 section of a CCNA service provider, we have a 4 switches all interconnected via 2 trunk links that we'll be talking about in an upcoming video. So in case you were curious to see how this is actually supposed to work out, we need to have VLANs configured. We need to have VLANs, we need to have ports applied to those VLANs. So we'll go underneath the interface and put a port into a VLAN. And then we'll need trunk ports. So trunking will help get interconnectivity between the switches. Then we'll talk about VTP and how you dynamically propagate VLAN information and go from there. So as you can see up here, I have some VLAN information up here, down here, and right here. So the 4 square circles that I have drawn are going to be the VLAN information that you guys are going to be seeing as we progress through here. Now, where this comes into play and where you need to be focused here is going to be on what exactly a VLAN does. So basically the idea here is, let's say you have a switch. Okay, you have this switch sitting here, and you've got, I'm just going to draw a few squares here, and these squares are going to basically identify a switch port on the switch. So you can plug in a Ethernet adapter into this guy and connect into the switch. So normally with the switch, by default, all ports in a Cisco switch are in VLAN 1 by default. Now, one thing that most people don't realize is VLAN 1 is not just used for data forwarding. It's actually used for a lot of the control plane traffic that goes around. That's one of the reasons why you can't delete VLAN 1, you can't remove VLAN 1, you can remove all the ports from being in VLAN 1. But when it comes to VLAN 1, you have to allow it to be able to be go across trunk links and things like that. It has to be at least able to communicate on some of the links in order for control plane traffic to be able to forward. So CDP, spanning tree protocol, and some other different control plane mechanisms work on VLAN 1. So that's one of the reasons why you can't get rid of it. So now the way that this actually works out, and again, we talked about this earlier, but a VLAN equals a subnet equals a broadcast domain. Okay, so what that means to you and I is when you place a port into a VLAN, it's not, even though you go to the interface level, you type in interface fast 0/1 and you type in switchboard access VLAN 10. So you're not placing the VLAN in the port as it may sound because you're typing in switchboard access VLAN 10. You're actually telling the port which VLAN is going to reside inside of. So it's a little bit of a difference, little weird when you first think about it, because the way you configure it, it makes it look like you're applying the VLAN to the port, which is how the syntax kind of lays it out. You might think of it, but in reality, you're actually telling the switch port which VLAN it's going to sit inside of. That's what you're actually doing. So instead of you going to like going into say VLAN 10 and then saying interface fast 0/1, where you'd literally be going into the VLAN and putting that particular port into that VLAN. Cisco does it the other way. You go to the interface level and you put the port, you give it the VLAN information at that point. So either way you want to look at it, you're placing the port into the VLAN. Now, why is that so vitally important? Well, when you're dealing with switches, and this is how typical networks operate. Now, the way that this is actually going to work out for us, and this is exactly the reason why I'm showing it to you this way, is that we're not going to have to basically drill home the reason why you would want to have a solid layer 2 environment. Now, before I go any further, let me explain what a layer 2 environment is going to consist of so that you have an understanding as to why I'm doing what I'm doing. So a layer 2 environment is going to consist of switches. They're going to consist of trunk links, which are going to interconnect your switches. And then you're going to have VLANs that are applied to the interfaces. So even though I just went into a little hiatus on you actually put the port into the VLAN, you actually do the configuration at the port level. Then you have your VLAN propagation. You may or may not use VTP. It's up to you and how you want to do that. Technically, VTP is always used, but to what level it can actually it be administratively implied varies on your implementation. So you have switches, you have trunks, you have VLANs, you have .1Q tagging, which we haven't really got into .1Q tagging yet. We will down the road. So what you're actually going to be doing here is, with router 1 wants to be able to talk to router 3, what will end up happening is your communication is actually going to leave gig 0/1, come in on gig 0/1 on switch 1. It's going to go across this trunk link here on gig 1/1 and 1/2 on switch 1 going to switch 2, and then that traffic is going to leave out gig 0/2 on switch 2 and come in on gig 0/2 on router 3. So your communication is actually going router 1 to switch 1, to switch 1 to switch 2, switch 2 to switch to router 3, and then vice versa. So as you're going through here, we're setting this stuff up. Even though I have the uplinks, that is just there for redundancy capabilities. So if I decided to, I could come in here and, if I wanted to have high availability, I could do so. But it's just connected this way. This is the physical connectivity. The logical connectivity is going to be a little bit different. So, but I wanted to give a physical wiring breakdown to how this is actually going to work so that you guys would understand it. Instead of saying, like, if I was to just draw a line from gig 0/2 to gig 0/2 and say VLAN 13 here, that's going to confuse everybody. Because you're going to be like, well, how does that work? How are you connecting that? When in reality, the physical connectivity of it is actually router 1 goes to switch 1 connects to switch 2 connects to router 3. And that's how the traffic is going to get forwarded. And then so like if I send a ping from R1 to R3, R3 is going to follow the same path back. And to switch from switch 2 to switch 1 and then back up to from gig 1 to gig 1 on R1. So that's going to be how that works. Now, in order to make this work, there's several pieces of information and configuration that need to be put in play. The first of which, we need to create a VLAN. Now, the VLAN is going to be a way for you to segment the switch into multiple broadcast domains. Now, as I've already mentioned in a previous video, but I'm going to hit it home again just in case you're still not 100% with that, or you didn't watch that video and this is the video you're watching. When you are taking a switch, all ports are in VLAN 1 by default. You go to the interface level. So you type in, INT gig 0/1. Underneath here, you could type in switch port access VLAN 10, assuming you've already created VLAN 10. If you have not created VLAN 10, the switch will automatically create it for you as long as the switch is in what they consider to be a VTP configurable mode. So either server or transparent. We'll talk about that more later on. But just for the sake of argument, it'll create the VLAN for you. Now by doing that, it's going to go ahead and create it for you, and everything's going to be good to go. Now what that basically implies to you and I is that now on gig 0/1, this guy's going to be in VLAN 13. Right? That's all well and good. Now, beyond that, that port is technically isolated from the rest of the switch. And you might say, well, how's that? Well, because every other one of these ports that we have here, gig 2, gig 3, 1/1, 1/2, 2/0, 1/3, they're all in VLAN 1. So in order for this to work out, in order for me to be able to move any type of traffic that comes from R1 that hits switch 1 that is destined for router 3, I need to have an interconnection here. So what I would do is I would make gig 1/1 and 1/2, I would make these guys trunk links. Now a trunk link, if you're not familiar with this, is going to allow 2 or more VLANs to cross it. So this is how your interconnectivity between switches works. Whether this is an Ethernet connection, whether this is a fiber optic connection, or whether this is a stack-wise or a VSS or a VPC, depending on what platform you're on. Now, if you're using Ethernet, that's a standard operation. That's actually how we're doing it here, is Ethernet. If you're doing where you have fiber optic connectivity, whether it's 1 gigabit or 10 gigabit, that's pretty typical of most deployments that I've seen or I've been involved in, or you're doing stack-wise. Even if you're doing things like VSS or VPC, you're still going over fiber. In most cases, you're going over fiber. If you're doing stack-wise, you are not going over fiber. You're going over using the backplane extension cable, the stack-wise cable that is literally plugged in and screwed tight into the back of the switches that basically makes two standalone rack mount switches, like a 3750 or a 3650 switch, look like one switch. So if you have 2 or 3 of these switches that are stacked together, you stack them together with the cable, and then once they come back online and they're all good to go, they appear as one switch from a logical perspective. So from a physical cabling perspective, they're 2 different switches, but from a logical perspective, both configuration-wise and from the command line, they look like one. So you would need that to happen. So you would configure these ports right here as trunk links. Now that would allow you to propagate VLAN information from switch 1 to switch 2 and from switch 1 to switch 3 and go from there. Now what I'm actually going to do here, I'm just going to cross this guy out here real quick, and I'm going to say 13. Now this port right here is in VLAN 13. No other port is in VLAN 13. Now this assumes, and in order for this to work out, in order for a VLAN to be operational, which means up and forwarding traffic, at least one port, access port or trunk port, has to be in a VLAN, and there has to be a cable plugged into it. There's no getting around that. So as long as you have a port that is up, you can go ahead and place that VLAN or that interface into a VLAN, and then from there, let's say for instance you see the VLAN 10 is down. So down meaning that there's no interfaces in that VLAN. That means there's no physical ports that have a connection plugged into it, and there is no interface VLAN configured for it. Now, if you see up-down, to where there's a cable plugged in, but there's no port physically, or there's no port that has that VLAN applied to it, then it'll be up-down. So that's going to be a case that you could see. Now, this applies for both access ports that connect down to an end device, whether it's a router, a printer, a computer, a server. It doesn't make a difference. As long as this port right here is configured as an access port and connects down to an end device, this is going to be an access port. Now, this also applies for the VLAN being up, that it's allowed across the trunk. So if you were to type in the switch port trunk allowed VLAN, 13, and that was the only thing you allowed across that trunk was VLAN 13. That's because that's what they call the trunk allowed list. Then that port would be up. Now, if you went in here and said no, or if you typed in switch port trunk allowed all or except VLAN 13 or something like that, I forget the exact syntax off the top of my head, but if you were to type that in, that would allow it would not allow VLAN 13 to cross that trunk. And if this guy right here wasn't inside of the interface, if this guy wasn't plugged in and powered on inside VLAN 13 would never come up. So it would be down. So that's going to be a key factor there that's going to determine how things are set up. So I'll show you guys what that looks like as we move forward here. So for the sake of argument, we're going to say that both gig 1/1 and 2 are both in VLAN 13. So I'm going to just draw a big 13 right there. And this side over here is also 13. And this port right here is in VLAN 13. So gig 0/2 is in VLAN 13. They would all need to have VLAN 13 configured on them because of the fact that you're traversing traffic through there. Now, why is that important? Well, what's actually going to happen here is when you have traffic that is going to be leaving out a switch to go to another switch, when it's leaving, it's actually tagged. It's encapsulated. And this encapsulation is known as .1Q tagging. This is a 4-byte tag that is placed just after the layer 2 header. And this is going to indicate, and it's only applied when it leaves the switch and goes on a trunk link, or when it's going to a router that's configured as a trunk, or if you have gig 0/1 configured as a trunk port and it's going up towards the router, it would also apply the tag, but we'll talk about inter-VLAN routing in an upcoming video. The way this would work out is if I'm going to go in here and get this stuff situated, I need to make sure that VLAN 13 is tagged as it goes across this trunk. So I would type in switchboard trunk encapsulation .1q, and then as traffic was going out switch 1 to come in on switch 2, any frames that R1 would be sending R3 or any other port that it's destined traffic to, it would encapsulate that frame as .1q for VLAN 13. So we get a tag. The tag would get applied to the layer 2 header. The traffic would go across the trunk. Switch 2 would receive that. Look at the layer 2 header, see the .1q tag, and say, oh, you belong in VLAN 13. The tag tells the incoming switch, or the switch, that the incoming frame belongs in VLAN 13. Now, the one thing that's interesting about when you create a VLAN, you're creating a VLAN, you're creating a MAC address table, and you're also creating a spanning tree instance. So spanning tree instances are created on a per VLAN basis. So if you have 200 VLANs, you have 200 spanning tree instances, one for every VLAN you've created. You also have 200 MAC address tables. So that's going to be another key thing to keep in mind. Now, your switch may not support 200 VLANs. You may have 1 through 4094 capable of being configured, but total configurable might be only 200. It depends on the platform. So as we go through here and set this up, I'll actually bring up Secure CRT here in a moment, and I'll show you guys how to create this. The key factor here to make sure you understand is that when traffic is when you're configuring these switches, you have to make sure that the correct VLAN information is applied at the right interface. So that's going to be the key factor there. Now, once you've done that, you've effectively isolated this port from the rest of the switch. And that's actually what you want to have happen. So as traffic comes in from R1, hits switch 1, and goes out towards switch 2, heading to R3, it's .1q encapsulated inside of VLAN 13. This switch 2 receives it, says, okay, you need to be placed inside of VLAN 13. And in this case, only one port is in VLAN 13. So the only possible exit point at that point is gig 0/2. As long as gig 0/2 has learned the MAC address of gig 0/2 of R3, then he'll know how to forward it. Now, we're not going to be talking about trunk links in this video. That's coming up here soon. But I just want to make sure that you guys understand the factor of the VLAN information. So let's go ahead and create a VLAN on our switch and see exactly how that works out. So we're going to go to switch 1, and I'm going to log in. I'm going to go log in, go to global config, and the first thing I'm going to do is I'm going to say, let me exit out here first, and I'm going to type in VLAN. In older code, I believe on the 2950s, on really old 12.2, 12.1 code, you used to be able to use the VLAN database. Well, Cisco has since deprecated that, so you no longer can do that. In order to create a VLAN, you need to go to global config, and we're going to type in VLAN 13. Okay. Now, by doing this from here, what we can do is we can come in here and do quite a few things. We can go in here and I want to name it. So I would type in name. We're going to say is going to be R1 to R3. Okay, I did that. So I'm going to exit out of here. That slight pause you just saw on the switch was the actual configuration taking place. So if I type in do show VLAN brief, you're going to see that I have VLAN 13 configured, and it's all good to go. Now, the way this is actually going to work, I'm going to go in here and type in no VLAN 113. That guy's gone now. So the way this is actually going to work out as we move forward here is I need to go to switch 2 and do the same thing. And the reason why I need to do the same thing is because of the fact that switch 2 needs to be able to forward traffic to R3. Now let's do a do show IP interface brief. Right now, the port is up on gig 0/1. If I do a do show MAC address table, you're going to see that I've got 15 total MAC addresses learned. And if we do a do show MAC address table for interface gig 0/1, we're learning a MAC address in an interface. If we go to router 1, you would see that this guy here, we do a show interface gig 0/1, this address right here should match this address right here. And it does. It's the same address. That's how you know what port is talking to which port. So I'm going to go ahead and on switch 2, I'm going to create VLAN 13. I'm going to name it R1 to R3, and then I'm going to place that in gig 0/2. Okay. I'm going to go ahead and do that. Enable config t. Host name is switch 2. I'm going to say VLAN 13. I'm going to say name is going to be R1 to R3. Now, if I type in do show VLAN brief, notice how it didn't actually do anything. If I type in no VLAN 113, if I type in do show VLAN brief now, it should take that configuration, and it does. That's going to be the key factor that we want to make sure that we understand. So, but we haven't applied the VLAN to a port yet. If we type in do show VLAN brief, the port hasn't been applied to the VLAN yet. So how do we do that? Well, we have to go underneath the interface, and we have to say switch port and access VLAN, and we have to say the number of the VLAN. In this case, it's going to be 13. So we type in do show VLAN brief now, you'll see that we've moved gig 0/1 to VLAN 13. Now I also want to type in here, if we do a do show switch port or interface gig 0/1 switch port, that's going to let us know what is going on at the port level. Well, this guy here is static access, is the operational mode. Dynamic mode is dynamic auto, which is the default for all switches that Cisco puts out. Except, I'm sure, well, at least all the Catalyst switches that you'll see in the enterprise space. That might differ a little bit from the Metro Ethernet and the Nexus line. But what you're going to see here is the negotiation of trunking is on, and what this basically means is that it's dynamic auto. So it's going to try to negotiate whatever it can. So what I'm going to do is I'm going to type in switch port mode is access. Okay, I'm going to do a hit the up arrow again for this guy, and you'll notice that the static access has now been is the administrative mode. That means that's what we configured it as. Before it was dynamic auto, which means that the switch is trying to negotiate a trunk link, then it's going to try to negotiate an access port. We are static access, and notice the negotiation of trunking is off now because we are now statically configured as a access port. If we type in do show run interface gig 0/1, you'll see that I am in VLAN 13 and my mode is access. So everything looks good from there. We're going to do the exact same thing on switch 2 on gig 0/2. We'll type in interface gig 0/2, type in switch port access VLAN 13, and I'm going to say switch port mode access. Do show VLAN brief, and you'll notice that gig 0/2 has now been moved to this particular VLAN. So these router 1 and router 3 should be able to communicate with each other now. If we type in do show interface trunk, there's no trunk links configured. So what that's going to mean to you and I is right now traffic should not work. If we go to router 1 and we do a show IP interface brief, I should not be able to ping 10.1.13.3, assuming that's what the other end of the link is configured as. And it is. So we should not be able to ping. If we can, then there's something else going on. Alright, so far I'm not able to ping it, and that's the expected outcome. And you might say, well, why won't it work? Well, for one, we don't have the trunking configured between switch 1 and switch 2. So if we go to switch 1 and we do a do show interface trunk, I don't have a trunking link configured. If I type in do show CDP neighbors, I'm going to detect the other switch, but I'm not going to be able to do anything with the capability because I'm not actually I'm not distributing MAC address information between switch 1 and switch 2. So if I type in this, I do a do show MAC address table for VLAN 13, I'm only going to have one MAC address. If I do the same command on switch 2, I'm only going to have one MAC address. And if we look at the MAC address table of router 3, that's my MAC address. The addresses match up. And the reason why they can't talk to each other is because trunking is not enabled. We'll talk about trunking in the next video. Actually, we're going to talk about access ports and trunk ports and why they're so, why they're so widely needed. And then we'll talk about trunk links after that. But we'll take a look at how that works out, and then that's going to be the main reason why this isn't working yet. And then that's actually going to be the next step, is building the trunks so that we can get traffic between switch 1 and switch 2 to work. And then we'll go through and take it for the next step from there.